Hi, this is Christopher Boucher, and I'm going to review a complement and then it's going to go into what we would call an at least type of question with probability. Now, well, this question, the at least part of it is it's essentially a cumulative binomial distribution question. When we are talking about this topic in statistics, this probability part, we're not usually to the part where we're talking about discrete probability distributions. So if I say it's a cumulative binomial problem, it probably doesn't make too much sense, but I'll try to explain it in a way that it'll click once you look at the binomial part and see how it works, or discrete probability distribution. Okay, so here's the question. The probability an inexperienced climber will get up a mountain above 20,000 feet without getting altitude sickness is 0.72, or 72%. So then, part one, what is the probability a climber will get altitude sickness climbing above 20,000 feet? And then part two is, what is the probability at least one climber out of two will be able to climb above 20,000 feet without getting altitude sickness? So this first part, the setup, is the probability an inexperienced climber will get up the mountain above 20,000 feet without getting altitude sickness is 72%. So for this first question, question part one, the question is, what is the probability a climber will get altitude sickness climbing up the mountain above 20,000 feet? So we have the probability for the person getting up the mountain without getting altitude sickness, but we don't have the probability for the person getting altitude sickness. So this is what we call a complement. It's also called, in probability, it's also sometimes called prime, and it's essentially all of the other probability other than the stated probability. So it's everything else. It's what is not. Okay. So all that we usually do with these is we have to take our known probability and subtract it from 1. So it ends up being like this. Make sure I'm on the screen. It ends up being 1, and then we subtract whatever our probability is. So we take that stated probability, subtract it from 1, and this gives us our answer. So in this case, what we have is we have 1, and then we subtract the probability, which is 0.72. And just to make sure I'm right here, our answer is, what is that, 28. Or written as a percentage, which probabilities essentially are 28%. Okay, so now the second part is a little bit harder, and it's where I'm going to focus most of my attention on this example. So number 2 uses the at least, and at least, when we say at least 1, what we're doing is we have to find the probability for none. And it kind of doesn't make sense when you're first thinking about it. Like I said, later when you look at discrete probability distributions with the binomial, it's kind of what this is. Now we can solve it really easy with this type of calculation. So what we do is we end up solving for 1 subtract the probability of none. And this gives us our answer. So if we're thinking about the what it would be, the none is now the none, what we do, because we're working with 1 out of 2 climbers, we have to find what that none would be. And to do that, we do this. So I'm just bringing down the theory. We do the probability of. Now for none, we are looking for the complement of each climber. The complement in this case would be 0.28. 0.28. So that's the complement, which is what we have right here. but we have 2 climbers, so we put in 2, and we're going to multiply them together. And what we end up with is, and I'll explain more in just a sec. We end up with 0.07. I have it written down, so I'm just looking at it. And then when we subtract it, we end up with our answer, which is 0.9216, or about 92.16%. And I'll scoot up. Okay, so the answer for this one is 92.16%. That we will get at least 1 climber out of 2 will be able to climb above 20,000 feet without getting altitude sickness. So we have a 92% or 92.16% chance that at least 1 will get up the mountain without altitude sickness. So how does this work? I want to spend the rest of the time with this. So what we do, like, why do we solve for none? This is the part that doesn't make sense to people. So we'll say this is, if we look at probabilities, we're looking at the number of people within this. So this one, let's just say this area is none. And then this one is going to be 1. And then it's not quite proportional. Let's say this one is 2. So what we do, and this will make a little bit more sense, what we do is we solve for none. So on the probability world, this is 0. This is, like 100%. So what we do is we solve for this area right here. And that gives us at least 1 or 2. Well, when we say at least, we're looking for everything other than what is less than our at least. In this case, we're looking for at least 1 climber. So we go and we solve for none, and that gives us at least 1. So it's 1 or 2. Now, in the binomial world, we go and we do binom CDF in, say, a TI-83 or 84 calculator, and we end up getting the answer. Then we just subtract it by 1, and we get the same answer. So it all does make sense. It's just this is a little bit of a peculiar way of doing probability when you think about it, that we're solving for none when we're looking for at least 1. But that's the way it works. Thank you.